Okay. So today we are going to begin by continuing with related rates. 6. And I'll leave some time for us to review at the end.
Yeah, so it's 4.1.
Yeah, it's 4.1.
It's 4.1, yes.
Plus 10.
Okay, so related rates, you should have your handouts. We actually did one of these problems before. I believe we did problem 3. Let's actually do some more. So, related rates basically, as I said, it's how when two different quantities are related, their rates end up being related in some way. So we're trying to figure out how rates relate to each other and use these to solve problems. So that's basically what we're doing. So you have the handout with the steps there. You always go through these steps unless one of them is done for you or you don't have to do one, but you always try to do things in this sequence. So it's a matter of really learning those sequences. The words I put in bold are kind of the ones you should remember, and the words that are not in bold is just to further explain what I'm talking about. So steps for related rates, what are they? First, the problem. Read it again. Did you read it? Read it, right? You need to read it very carefully, right? There might be a lot of nuances to it. The second thing is to do what?
Draw a diagram.
Draw a diagram if possible or necessary. Now the purpose of step 2 to draw the diagram is to be able to figure out a formula that you're going to need in step 4. So if you're either given a formula already, you don't really need to draw a diagram, or if a diagram is given to you, you don't really need to draw a diagram, but other than that, you kind of should. So that's step 2. Step 3 is just set up your game plan. Write down what you know, what you want to find. Step 4 is to come up with a formula that relates all the variables. And then you're going to differentiate with respect to t, and then you're basically plugging your knowns and solve for your unknowns, whatever you want. And that's basically the method of related rates. It uses implicit differentiation, and we're going to apply that. And yeah, I also posted a handout on the website, so if you guys lose it, you can download it again. So let's actually continue here and get through a few problems, and then we can start on our review. Let's go to the examples. Problem 1. A right circular cylinder undergoes expansion. Its radius is increasing at a rate of 1 meter per second, while its height is increasing at a rate of 2 meters per second. At what rate is its volume changing when the radius is 1 meter in length and the height is 3 meters in length? Okay, so step 1, we read the problem. Read. Step 2. Diagram?
Yeah.
What is that?
Cylinder.
It's a cylinder. Right circular cylinder. Okay. So which part of this is the radius? This is from the center to the edge. That's our height is here. Now, remember, we label things that are changing with variables, things that are not changing with constants. We are told that both the radius and the height are changing, right? So I'm going to use r and h. If any one of these were fixed, I would put a constant, right? It's very important that you label things in an intuitive way, right? So now, we're going to step 3. What do we know? What do we want? What do we know so far?
The height, which is dh dt, is 2 ms.
We know that dh dt is 2. We also know dr dt. That's 1. Right? So the radius is increasing at a rate of 1. The height is increasing at a rate of 2. And what do we want?
What's the radius and the height's 3? The radius?
Is that what we want? What did they ask?
Volume.
Volume.
They didn't ask us for volume either. Read.
At what rate is the volume change?
So what did they ask us for?
The rate dr dt at a certain.
dV dt. They asked us for the rate of change of the volume. I already know dr dt. They wouldn't ask me for that. Right? So V is the volume. I want that when what happens? R is 1 and H is 3. Okay. read very carefully, right? You're looking for the rate of change of the volume, which means somehow I'm going to have to come up with a formula that will relate all my variables, my v, my h, and my r. Formula. So, what's the formula? Anyone remembers the volume of a cylinder?
Pi r squared cube times height. Wait. Pi r squared.
H.
So V equals pi r squared h,
Yeah.
right? Anything that's a cylinder that you have that same shape being moved along some axis is the area of the base times the height, right? So the area of the base is pi r squared and times the height. So that's the volume of our cylinder. That is a formula that relates all my variables in question. 5 is to differentiate that equation with respect to t. That is step 5. So what is the derivative of this equation with respect to t? Derivative of v? dv dt equals,
Pi. Or
Zero.
no,
No, isn't it the product rule?
product rule, right? I have one function times another function. Remember, with respect to t, what?
How did you know to group pi r squared and h?
They're two different variables.
They're two different variables, they're two different functions. What do you mean?
But there's an r too.
So I'm assuming you assumed like pi was a constant.
Pi is a constant, yeah.
So that's why you, okay. No, well, okay.
Yeah, I could literally attach the pi to either one. I could also leave it out. It wouldn't matter. It's a constant, it's gonna just stick on to the side anyway. Right? But it just seems easy to do that, just have two groups of things. So remember, you're always thinking of what rule you need to use to differentiate something. There are two variables here, which means they represent two different functions. They're multiplying each other. We're going to need the product rule, which means we need the two pieces. That's my f, that's my g. So now what's the derivative?
6.28.
Oh, okay.
Oh, 2 times pi, sorry.
2 pi, yes. Pi is pi, that's fine. 2 pi r
dr dt. Times h.
Plus
plus
pi r squared.
Times
H. dh.
dh
dh dt. Right. So we did the product rule. Whenever I differentiate on r, I have to put dr dt because t is my independent variable, which means r is like this function that I don't know. So I have to multiply by the derivative inside. Same thing with h. Right? So I do the product rule, and that's that. At this point,
Could you just substitute?
I can just substitute. I literally know pretty much everything, right? 2 pi, I know my r is 1. I know my dr dt is 1. I know my h is 3. My r is 1. My dh dt is 2. So this comes down to 6 pi plus 2 pi. And this was what I want, so I stopped there, right? dv dt is 8 pi, and it's a volume, so it would actually be meters cubed per second. But I don't particularly care if you write the units or not. In physics class, writing units is super important, but here I'm not going to really care. Units are important for you when you're actually reading a problem. So when you're reading a problem, read carefully. You should know that if they give you a units in cube, it's talking about a volume. If they give you a square, it's talking about area. If they just give you just the unit, it's just talking about the length. Right? So things like that you should know, but I don't particularly care if you put a unit in your answer. Yeah, that's the process. Right? So this was step 6 happening here to plug in what I know to solve for my unknowns, right? It's always the same process. You read, come up with a diagram, write on what you know, what you want to find, come up with a formula that relates all these guys, differentiate with respect to t, which means everything that's not a t, you have to multiply by its prime when you're differentiating it. Then you plug in what you know, solve for what you don't know. If at this point there was something that we didn't know, you would go back to this formula here to figure it out and come back and plug it in. But in this case, we actually knew everything, so we just plugged it.
I have a question.
Yes.
So you see when you write dv dt, drh over dt
Yes?
before everything,
Hmm?
that do you need to write that?
Need to write what? Which part?
dv over dt.
Yes.
dr over h.
Yeah, because you're differentiating the entire equation, so I have to differentiate the left side and the right side.
Okay, so those things just pretty much like show that you're taking the.
Yeah, I'm taking the derivative, differentiate the equation.
Okay.
So I'm taking the derivative, right? So dv dt is like my v prime, this is my r prime, this is my h prime.
Okay.
Yeah, you have to write that. Any other questions?
That's where you get the units for at the end, which you put back in, right?
Right.
If you didn't keep track of dr dt over dt, you
Yep.
wouldn't know what your
Right, so this would be in meters, this would be in meters per second, that would be in meters. Or-
3 meters, yeah, meters.
Yeah, we have a bunch of meters and you can keep track of the rules that way. So here's you have a meter square and a meter, and that gives you the meter cubed. So that has meter, 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 that gives you a meter cubed per second, and this is a meter cubed per second. So you can keep track of the units to make sure things are working out. Once you set this up correctly, it should work out. What about problem 2? One, read. The particle is moving along the curve y equals x cubed plus 1 in such a way that its y coordinate is increasing at a rate of 2 units per second. At what rate is the x coordinate changing when y equals 9? So 2. What would we do for 2?
You draw the graph?
I could, but basically I'd skip it.
Yeah.
Why would I skip it?
You already have.
I already have the formula, right? I don't need to figure out, oh, it's a triangle, so I could try use Pythagoras theorem. The whole point of doing a diagram is to help you figure out a formula. Right? So I can literally skip it here because I already know the formula. 3, what do I know? What do I want to find?
You know your dx dt?
I know my, it says its y coordinate is increasing at a rate of 2. So I know my dy dt. And it's increasing at a rate of 2. And what I want is dx dt at a certain instant. I want dx dt when y equals 9. Which brings me to step 4, which was actually done for you. They gave you the formula. Y is equal to x cubed plus 1. So that's my step 4. Step 5, I'm going to differentiate both sides with respect to t, which means both of these guys are functions of t. So
dy
dt.
I get dy dt equals
3x squared dx.
right, derivative of 1 is 0. And at this point, I want to find dx dt when y equals 9. So I know this. I want to find that. I don't know x. What do I do?
The x alone.
go back to your first equation.
Right, so if there's something here that I don't know, go back to step 4. So now I know when y equals 9, this means I have 9 is equal to x cubed plus 1. Which means 8 is equal to x cubed, which means x equals 2. And so now I'm going to go back and plug that in here. This means dy dt equals 3x squared dx dt. And so I get my dy dt I know is 2, my x I know is also 2, and dx dt is what I want to solve for. Can divide both sides by 2, which means that I have 1 over 6 is dx dt. There's a part B to this question. This is part A. At this instant, how fast is the distance between the particle and the point 2, 10 changing? Good. What do you think for this one?
Would we plug in X and Y coordinate?
Plug in X and Y coordinate? What did it ask us for? So this is like a whole new problem actually. So we're going through the steps again. One, we're going to read. What do we want to find? How fast is the distance between the particle and a certain point changing?
It's the slope, the rate of change.
Did I say the rate of change of what?
Between two.
Rate of change between the 2 points. What does that mean?
The distance.
The slope?
Slope.
No.
Like change of while, change of. Okay, forget.
Nope.
The tangent line.
You don't really need a diagram here, but I'll just illustrate it. X cubed plus 1 looks like this. Right, this goes through 1. So I have my point 2. So I'm up here 2. 2, 10. So that's going to actually be above this graph. Now I'm at the point x equals 2, 8. Right? What are they asking me about on this picture?
How fast it's changing.
How fast is what changing?
The distance between the 2 points that you have in the
Right,
graph.
so you see this distance here, d, that's what they're asking me about. Right? Now, how do I find the distance between these 2 points?
Is that
Is that the
Implicit differentiation.
square
Well,
root?
remember, before we even get to differentiate, we have to figure out what we're going to differentiate.
Is it
So
like
first, 2, 1 was read, 2 was this, 3. What do I know? What do I want?
How did you get 8?
Because this function is x cubed plus 1. Y is x cubed plus 1. So when my x is 2, the y value is 8, but now I'm at 2, 10.
okay?
So what do I know? I know my dy dt at this point. I know that's 2. I know my dx dt. That's 1 over 6. And what I want is the rate of change of distance. Maybe I should call the distance a different, call it uppercase d. I want dd dt when x equals 2, y equals 8.
X.
Now we're in step 4. I need to relate all the variables that I see. I need to relate x to y to d. How would I relate x and y and d? Distance formula. What's the distance formula between 2 points? Right? So let x comma y be a point on the graph. Right? And so 2 10 is another thing. I need the distance between these. Right? So the distance formula equals d, which is going to be remember it's the radical of x minus t squared plus y minus 10 squared. Yeah, you have to remember the distance formula. You have to remember a bunch of forms for related rates. So geometry is going to be coming back. You have to remember like stuff about cylinders, distance formulas, equations that go with triangles, all that stuff. So that's the distance formula. This is a very typical kind of problem actually. We can actually cheat a little bit here. Since radical x is an increasing function, I was thinking of optimization. Never mind. We're going to use that formula. However, so that's our formula here. There's another case where we can cheat, but it's not really in this section. So that's our formula. This relates to d, the x, and the y. Now that's kind of ugly. How are we going to differentiate that? Brings us to step 5. Derivative of d. Sure, I can look at this as x minus 2 squared plus y minus 10 squared to the 1/2. Derivative of this, dd dt equals, what's the derivative of that? Chain rule. Differentiate the outside, x minus 2 squared plus y minus 10 squared to the minus 1/2 multiplied by the derivative of the inside. So derivative of the inside is what? I have to differentiate this guy, which is what? Times what?
1 minus 2.
Chain rule again, right? You differentiate the outside, multiply the derivative of the inside. What's the derivative of x minus 2? Nope. dx dt. Don't forget, you're doing implicit differentiation. T is the variable. Plus 2 times y minus 10 dy dt. So now I have that. This brings me to step 6. I'm going to plug in what I know and what I want to find. What do I actually know here? It says at this instant, right? So we know that our x is 2 and our y is actually 9.
Yeah, I was like, how are you getting 8?
Yeah, that was enough. So I'm pretty much going to go here, plug in everything I know. I'm going to plug in x equals 2. So all those guys are going to go to 0. Right, that's just 0. My y I'm going to plug in 9. Right? So that just becomes minus 1 squared. So that's literally just 1 times, that's going to be 0. This is going to be left with 2 times minus 1 times dy dt, which was what? What was dy dt? 2? Right? That's this one. 2 minus 1 dy dt. This one is 0 because my x is 2, so it kills that. And x is 2, so that's 0.
Oh,
And then this here is 1.
okay.
So this is 0, that is 0. And so at this point now I complete that answer. So that means dd dt would be equal to, well, 1 to the minus a half is just 1, so that's just a half. So that's just a half times minus 4 minus 2. The distance is, are we increasing or decreasing?
Decrease.
It's decreasing at a rate of 2 meters per second, right? That decreasing gives me that negative. So, which leads us to the follow-up question. Is the particle approaching 2, 10 or getting farther from it? This means the particle is approaching, right? Because the distance is actually decreasing between the two. So if you're closing the distance, you're actually approaching. Right? It means the particle is actually moving towards it. So we're actually going on the curve that way.
This is crazy.
Yep. Number 2 was kind of cheating. It was like 2 problems in one. But like part B could have by itself been a problem.
Mm-hmm.
I just did that because I thought part A was too easy.
Oh,
Come on, man.
Let's actually do one more and then we can start a review.
Let's do number 8.
So we already did 3 last time. Let's jump into problem 4. At noon, a ship is 80 miles west of ship B. So ship A is 80 miles west of ship B. At this time, both ships set sail. Say that 3 times fast. Ship A sails south at a speed of 20 miles per hour, while ship B sails north at a speed of 10 miles per hour. How fast is the distance between the 2 ships changing at 2 p.m. if both ships maintain constant speed? So, mouthful there. So we read it again. 2, I don't know what the heck is going on, so I'm definitely going to draw a picture for this one. At noon, ship A is 80 miles west of ship B. So here are the 2 ships. Who's A, who's B?
Ship A is west, so it's the left side.
So it's all
Right, A is over here, because west, it spells we,
Yeah.
right? So west is on the left. So here's A and here's B. And I know the distance between them at this point is 80. Ship A is going to start sailing south, right? So ship A starts moving in this direction. Ship B starts going north. Now I stop the clock at 2 p.m. So they reach some point at 2 p.m. And then I ask, how fast is the distance between the 2 ships changing? So here's one ship, there's the other ship. I want that type, right? So what are the things that are changing here? We have to label this diagram very carefully, very properly. This distance here is not changing because they're not moving sides, right? They're just moving up and down. So that's always 80. What's changing?
The distance,
What distance?
north and south.
Right, this is changing because A is moving down, right? So I label that with a variable, whatever you want. Call it X. This distance is also changing because B is moving here, so that distance is increasing, so call that Y. What else is increasing?
The hypotenuse.
The hypotenuse, this guy attaching the 2, call that Z. Can you come up with Z? Okay, so now we're going to go with step 3. What do we know? What do we want to find? I actually know how fast A is moving, right?
yeah.
And I also know how fast B is moving. So A is, well, I would label it X. I call the distance as X and Y.
Okay.
Right, so the distance that A has traveled is X, right? And the distance B has traveled is Y. So dx dt is 20 and dy dt is 10. So they're both increasing, so these rates are positive. And what do I want? How fast is the distance between them changing? So I want dz dt when, what happens? What's the instant that I care about here? 2 o'clock.
2 t plus 2.
When they equal each other.
Nope. Usually we care about like what are the x values and the y values, right?
So it just times it by like
So what would x be?
40.
You're moving at 20 miles per hour and you've been traveling for 2 hours, right? It's from noon to 2 p.m. So what's x at this instant? It's 40. Right? 20 miles per hour times 2 hours, right? You get 40 miles. Similarly, y would be 20, right? Moving at 10 miles every hour, you've been traveling for 2 hours, so you covered 20 miles, right? So that's what you know, that's what you want. Let's get to it. What formula would describe the situation here?
Could you use this?
Pythagorean theorem.
Okay, how would you set it up?
So like you have, it looks like it's being cut straight in the middle, so you have like x, then 40, and then some random variable.
How do you know it's exactly in the middle? In fact, it's Probably not exactly the middle, because this one will be a lot longer than that one. It's not symmetric.
A proportion.
I want to show you guys a really cool trick.
Even 90.
Yeah. Yeah.
Is it gonna help?
I'm just gonna help. I'm gonna tell you something that doesn't help. See, you guys could confuse you guys.
Yes.
Look at this.
You're gonna write a square.
Do you see it? Did that help? Or just nah?
Wait.
Also, too hot.
Does that help? Like what now? What does that mean?
Too hot.
Look at this. What kind of shape is that?
Oh.
That's a right triangle. I just created a big right triangle where this is one length, that's Z. What's the base? The base is 80. What's the height? That's Y.
Mm-hmm.
That's what?
X.
So
X plus Y.
this distance is X plus Y. So I basically have now a diagram that looks like this. So what's my formula?
80 squared plus X plus Y squared equals C squared.
So Pythagoras' theorem. By Pythagoras, we have that Z squared is equal to 80 squared plus X plus Y squared. Step 5 now, we're going to start differentiating. Derivative of Z squared. Derivative of 80 squared, 2 times 80, right?
160? Oh, zero, wait.
I caught you guys, that's a constant. Derivative is 0. Derivative of this.
I can't trust.
What's the derivative of this?
It's
2 times X plus Y times 1.
To the 1
Oh,
times. Derivative of the inside is
dx dt dy
dx dt plus dy dt. Okay, so looking pretty nice here. I know x, I know y, I know dx dt, I know dy dt. Ah, z.
That's all.
Yes, z. I said it.
red full set.
Okay, how do I figure that out?
Start plugging in what we know.
No, go back to the original formula.
Go back to this formula. We have to figure out the z. So now, when x equals 40, y equals 20, we have that z squared is equal to 80 squared plus 60 squared. Right? One thing we can immediately notice here, that this is kind of, this guy here is 20 times 4, right? This guy here is 20 times 3.
Special triangle.
It's a special triangle, which means that z over here must be 20 times 5, right? So actually no, from here, z must be 100. So then I'm going to plug that in here. I have 2 times 100 dz dt equals 2 times x plus y is 40 plus 20, that's 60, times dx dt 20 plus dy dt is 10. 2's cancel. And so I have dz dt is going to be 60 times 30 over 100. So that's 18 miles per hour. Answer is obviously yes. Yeah, so that's actually a nice problem. Like that's like the kind of problem that would come on a final. Actually.
This is crazy.
Didn't really see that big triangle.
I should have never drawn
Well,
that.
now you know. It's a trick. Sometimes you can create a shape that's actually kind of not there.
I love how it's quite
Thinking outside the triangle.
Hexagon.
Yeah, if you know a form for a hexagon, sure, create a hexagon. I don't know a nice form for a hexagon. So there's that.
And that's it. Yay.
That's it for now. Let's go to the review. Okay, the review problems. Questions on the review problems?
Yes.
Okay, so maybe I should. We have this, right? I was gonna type this up into an email earlier. I'll probably still type an email. So with these topics and tips, but so some things I know for sure that you need to know at this point. You definitely have to know find f prime using limits. You're definitely going to need to know find the equation of a tangent line. Which could be part B to a problem like this. Of course, you're going to have to differentiate a bunch of functions. Both explicit and implicit. Right, so kind of like problem 1 on the past finals, where they have problem 1 part A, B, C, D, differentiate all these things. Yeah, there's gonna be a problem like that. Explicit and implicit. We will need, there's going to be marginal cost. And there's going to be a linear approximation. So that's basically just using a formula to approximate some function that I give you. So actually, approximate the square root of 15.9 or something like that. This is the linear approximation formula. I might do a problem like there was on one of these finals. I think it was problem 9 on one of these guys. I think I put spring 2010, problem 9.
Yes, you sure did. Oh, that's a port.
No, that's not PERT, but it's I did an example kind of like it. It's a gray area. I mean, you could kind of think of it as a related rates problem, but Yeah, I'll probably just, just this stuff.
Is there one you
I'll
would
probably
have
just
us
ignore that.
emphasize?
Huh?
Is there one you would have us emphasize?
There's the one,
Yeah,
what?
differentiation.
Is there like a specific topic you'd want us to like
No, this is it, this is what I'm
emphasize on?
Wait, what?
This
No,
is the
All of it,
comprehensive
all of
list
it.
here? This
this is it, this is what you need to know.
Roger.
This is the emphasis, this is, the whole thing is the emphasis. This is emphasized, right here.
Gotcha.
Alright, let's start from the top.
I'm gonna ask you to find a derivative using limits. Find the equilibrium of tangent line at a certain point after doing that. I'm gonna give you a bunch of functions, just say differentiate all of these, right? And of course, you're gonna have to be able to use all the rules, log rules, quotient rules, chain rules, product rules, everything. Maybe even a log differentiation rule, like an x to the x or something similar. Marginal cost function, kind of like the one I did in class. You know, here's the cost function. Find the marginal cost function. Approximate how much it would cost to produce one more item of blah blah blah. That kind of stuff. And I'm going to give you something to approximate. So I'm going to be like the square root of 15.9
Yeah.
or something silly, or the cube root of something, or some function I'm going to ask you to approximate using linear approximation. That's pretty good. That's basically it.
Any graphic?
No.
Is this test written or are you still working on it?
I'm still working on it, but I'm pretty sure that's it.
Okay, so I
Right now, we don't have to worry about graphing, but when we get to curve sketching, I'll catch you guys with the graphing. Don't worry about that.
That's where you'll
That's. Oh yeah, curve sketching is gonna be
Because
crazy.
you have it already.
Did we?
What?
Because you haven't already.
No. What do you mean? Yeah, but that's basically what it's gonna look like.
Okay, so can we do like 3 of each?
So yeah.
What do you wanna do? I guess you can pick a final and just go through.
I got all of them.
Yeah, let's start with the first one. Yeah,
Spring 2009.
Number 1. There's 3.
Bring these in random order.
Yeah, ready for you.
Follow 9.
Do you want my laptop?
No, I wanna write it. Oh, here we go. Spring 2009. So in the review we had it was spring 09. What problem did I say? 1, 5, and.
That was 10.
Okay. So in problem 1. So we're doing spring 09. We're gonna go through all the problems. Problem 1, it's like 3 parts, and they ask you to differentiate a bunch of stuff. Okay, so let's start here. Y is equal to okay. You see that? What do you do? Panic. No. What's the first thing you think here? Quotient rule, right? The first thing you always think when you see something, what rule should I be using? I see that there's something divided by something, right? Now there's a rule for that. If I want to differentiate f over g, the rule is
F
Prime. F prime times g minus.
G.
over G.
right. That's the quotient rule. So go.
Oh, okay. 1/2 x to the negative 1/2 times 2. I don't know.
2 plus ln x.
Yeah,
Like that.
parentheses
Parentheses.
minus
Minus.
x to the 1/2 times
What's the derivative of this?
1 over x
Just 1 over x over 2 plus ln x squared. Now this guy gives us what? If I take x to the half times 1 over x, what do I get?
x.
What's another way to write 1 over x?
X minus x to the
X to the
negative
minus
first,
1.
yeah.
What's x to the half times x to the minus 1?
X to the negative.
Negative half.
X to the minus half, you add the powers. Right, so over here, 2 plus x ln x squared. X to the half is a common term. I can factor that out. One half 2 plus ln x minus 1. But not much we can do after that. So I leave that. That's our derivative. B. ln of e to the x squared minus 1. First question, you ask yourself, what rule do I use? What rule should I be using here? Right. The derivative of ln u is u prime over u. U is just what's inside the ln, which is this guy. That's our u. So now the derivative is going to be that thing that's here. I'm just going to put it on the bottom. You just copy it. On the top, I need to put the derivative of this guy. What's the derivative of e to the x squared?
2x e to the x squared.
What rule did you use?
Yeah.
Chain rule. I know that the derivative of e to the u is u prime e to the u. So to differentiate this, I'm going to differentiate the power, which is 2x. I'm going to multiply that by the original function. And derivative of 1 is just x, right?
No.
Right. So that's your answer. It's kind of a one-step thing. But yeah, you see this, every time you see a problem, you have to think, what rule applies here? There's an ln in the front, so you go with the rule that has an ln in the front. And that's your answer. C. Y equals 3 over 1 plus 3 e to the x to 4.
Can you put it to the negative 4?
Sure, I would. 3 times 1 plus 3 e to the x to the minus 4.
It's negative 12 over that chain rule.
And now we use the chain rule. Because we have an inside function and an outside function. So y prime is equal to, bring that minus 4 down, leave the inside intact, subtract 1 from the power, then you multiply by the derivative of the inside.
3ex.
Right, which is just itself. And you could leave it like that, or you could just take this and multiply that. So minus 36 e to the x times 1 plus 3 e to the x to the minus 5. And that's it for problem 1. On the test, I probably put something like a part D where I ask you something like,
Come on.
and say find y dy dx. What would you do?
Implicit.
It's implicit. Okay, so this becomes,
3, yeah, 3. I mean,
I'm finding dy dx.
Okay.
Wait.
What does that mean?
this is where I get confused.
That's one of the y's that you differentiate.
Come again?
That's one of the y's that you differentiate.
Yes.
So it'd be 3y cubed dy dx.
Times y. Yeah.
Wait, what?
What did you just differentiate?
Don't we have two products here? 3x and
It's
y
a
squared?
product rule, right?
Yeah.
Yeah.
3 times 3x.
So you just differentiated 3x,
Right.
but your variable is x. So what do you do?
Oh.
I don't know.
No, that's it. See, y, z.
Nothing, right?
Yeah.
Plus, differentiate the y term, so this 3 comes down, you get 9xy squared
Times what?
times dy dx, or y prime.
Okay, let's take it back.
Got it.
Oh, you're doing it so fast.
Yeah, don't do that.
You're skipping a step.
Don't
I
do
didn't skip any
That's
steps.
like
See, look what you've done.
Can you,
Where did you get the nice?
say that in the?
You did 3 times 3.
I want to find dy dx. X is down here, which means if I differentiate an x term, I don't do anything at all.
Of course.
If I differentiate anything other than an x, I must attach a prime.
Yeah.
Right? Before we were doing implicit differentiation, remember the bottom was what? It was t. Which means when I differentiated x, I still had to multiply by a prime, because it's not the guy on the bottom. It's the guy that's on the bottom, you don't have to do anything. Right? So here, I want dy dx. When I differentiate x, I don't do anything. I just differentiate x. The derivative of x is 1. It's gone. Then differentiate the y, I have to attach dy dx. I have to attach that y prime. So here, what is this going to become?
Same thing.
Product rule again, so what does it look like?
3.
Y. Minus 3.
Minus 3y
Plus.
dy dx.
What did you just differentiate?
Yeah.
You just differentiated the x, right?
Uh-huh.
Don't do anything. Move on.
Plus.
Plus,
Minus. I don't know. Yeah. Just erase.
plus what? Hmm?
Yeah, 3xy, dy here.
Plus 3x
Oh,
dy dx.
dy dx.
dy dx.
No, I didn't, I said one.
Is that right? It's wrong. It's wrong.
Minus.
Well, it's
It's minus, because this is in parentheses. That minus would affect here. Alright? You have to do the product rule, but there's a minus on the outside. So technically this should be a minus here. Derivative of 2x
2.
is plus 2 equals derivative of this 10y dy dx. Right? Differentiate a y, attach y prime. Differentiate the x, don't do anything. So now what? I want to solve for dy dx. I want to solve for that. So what do? Get him alone on one side. So what is that going to look like? 9xy squared dy dx. Or this one, I'll just write y prime. Minus, bring that guy over, minus 10y y prime equals. Who's on the other side?
Minus 2.
Minus 2
Minus 3y squared.
minus 3y cubed. So I subtract this, I subtract that. Oh, there we had another dy dx.
Plus 3y.
mm-hmm.
So there is another dy dx. It's a minus 3x. So that takes care of that guy. That takes care of that guy. We took care of this guy. Who else we have?
Plus 3y.
Plus that 3y. So it's minus 2 plus 3y. And we've taken care of everyone. So now at this point, I just factor out the y prime.
Wait.
Wait, you
You're missing, you took
the
rewrite
the 3y cubed, the
The
first thing.
3y cubed.
Should
Oh
go
yeah,
on the
I
right
erased that.
side.
You didn't rewrite it. Okay, so now we have 9xy squared minus 10y minus 3x equals minus 2 plus 3y minus 3y cubed.
You just divide by that.
And then I just divide by this whole thing to get the y prime by itself.
Okay.
The next problem is problem 5, spring 2009. Yeah, there's going to be a problem on your test that looks like this. I'm just going to ask you differentiate a bunch of these things. One or two of them I'm going to use implicit differentiation with x's and y's are jumbled, and you have to do this kind of thing. So spring 09, problem 5. So this one says here our f of x is 4 over 3x, and it says using the definition of derivative in parentheses limits, compute f prime of 3. So that means you need to use limits to find the derivative. So the definition is what?
Limit
F of x.
limit as h approaches 0. F x plus h minus f x over h.
Okay, so now we're going to start to plug in. So what is f of x plus h here?
4 over 3 times x plus 8.
4 over 3 times x plus h in parentheses minus
4 over 3 x
all over h. What do we do now?
common LCD.
Common LCD, because it's a complex fraction. I have fractions inside of a fraction. So I'm going to multiply by the LCD, which in this case is
Everything, just do it.
3x times x plus h over 3x times x plus h. So then I take this guy, I'm going to multiply that, I'm going to multiply that, distributes. I didn't take the limit yet, I keep writing this limit, right? Notice that I keep writing this limit. Okay, so what's going to happen is the 3 will cancel, the x plus h will cancel, and I'll be left over than x. So I'll just have 4x here, minus the 3x will cancel, and I'll be left with 4x plus h. On the bottom, I would have h times 3x x plus h. What happens now?
So that'd be 4x minus 4x
4x minus 4x minus 4h.
over
Just goes that, and then my h will cancel into that one.
right?
And so I have a limit as h approaches 0 of minus 4 over 3x times x plus h. And at this point I can plug in h equals 0 to get 3x squared. Which means what they asked us for in the beginning, remember, was f prime of 3. That just means I plug in 3 for x. This is going to be minus 4 over 3 times 3 squared. It's minus 4 over 27 is our final answer. Now Now remember, at this point, you actually know how to find derivatives with a shortcut, so I would recommend that you actually check your answer. Right? Now if your y was 4 over 3x, how would you actually differentiate that?
Quotient.
No. Overkill.
The chain.
You do 4 times 3 to the next to the negative.
Yeah.
This is basically 4 over 3 times x to the minus 1. So we just do this 4 over 3 minus 4 over 3 x to the minus 2. So we get minus 4 over 3x squared, which is what we got.
Just in that last step, like we went from negative to limit of h as square to 0 and negative 4.
This one?
Yeah, and then to the next step, not just.
I took the limit. I plugged in h equals 0.
Okay.
So it's just x times x, using that x squared. Right? And you can do your shortcut here and say, oh yeah, we actually did that right, and then you move on. And so that was a part A. Now it says part B. Using the results of part A, find the equation of the tangent line to the curve y equals f of x at the point where x equals 2. That is a typo. That should be x equals 3.
Okay.
It's always gonna be the same point from part A, otherwise you're gonna have to recompute. So just scratch that out and put x equals 3. So now we want the tangent line at x equals 3. Okay, so question you ask yourself, what is the tangent line? What does the tangent line look like?
So the linear line.
So what is the one?
Y minus y1.
Y minus y1 equals mx minus x1, where you know that your m would come from the derivative at the point. Right? So here I know my m is, I just found it, minus 4 over 27. I know my x is 3. What is my y? Or my x1 is 3. What is my y1? Where? In the original function, right? So this means that my y is actually going to be 4 over 3 times 3, right? This is just going to be 4 over 9, which means my tangent line now is just y minus 4 over 9 equals m x minus 3. Questions on that?
So anytime they ask us to find the equation of the tangent line, you use the point slope form, you plug in the slope you got from the derivative, you plug in the point that you're given and solve.
Yeah.
For the other one by using the original equation.
Yeah.
That's it?
Yeah. It's always going to be like this. Yeah. What makes something a tangent line at a point is that the slope is from the derivative, but it's a straight line in every other sense of the word. So it was 1, 5, and 10 from this final. So spring 09, problem 10. Oh yeah, add this to the list. That was what I was forgetting. The speed, velocity, acceleration problem. So add that to the list of tips. I was forgetting something. I couldn't remember what I did. Yeah, so there's going to be something here. They gave you a position function. S of t is equal to minus 16t squared plus 128t plus 5. Okay, so it says a ball is thrown upward in the air. The vertical distance after t seconds is given by this function. And so A, they want velocity after 2 seconds. Right. Just remember that velocity function is just the derivative of the position function. So that's going to be
Negative 32 plus 128. Negative 64 plus 128.
right. So now they want v of 2. So it's going to be negative 32 times 2 plus 128. That's minus 64 plus 128, which gives us what? 64, right? It's going to be 64 feet per second. 64 is your answer. So at that point, it's moving up because it's positive. So it's going up at 64 feet per second. And then in part B, the axis for the acceleration after 2 seconds.
The derivative of that.
And then you have to remember that the acceleration function is just the derivative of the velocity function.
Just negative 32.
So it's just minus 32, which is the acceleration due to gravity in feet per meter squared. When you get to physics, you'll learn about that. But yeah, it's a constant function. It doesn't matter what your time is, right? So A of 2 is also just minus 32. It's always going to be minus 32. And it's feet per second squared. C. It says at what time is the velocity minus 32 feet per second? So it says when is the velocity minus 32? Well, we know what the velocity function is. It's here. So now I'm just going to set that equal to minus 32. So minus 32t plus 128 is equal to minus 32. So this means minus 32t equals, what's 32 minus 128?
What?
Minus 32 minus 128
160.
minus 160. And so t means that t is equal to 160 over 32. Does that go exactly?
Yep, by 5.
It's like 1.95.
Huh?
1.95.
It's 5.
It's 5? Okay.
Yeah. 32 times 5.
Okay. So after 5 seconds, the velocity is going to be minus 32. So it's going to be heading on the way down, and the speed will be 32 feet per second. And then D says when is when's the ball at height 117? Okay, what do we do here?
I'm still kind of stuck on C.
Oh, okay.
So like when they ask you.
Yeah, C said at what time is the velocity minus 32 feet per second, which means you're looking for a time first of all. And you want the time when the velocity is minus 32.
Didn't we just solve that though in the early
Yeah.
B?
No, B was talking about acceleration.
Okay.
B is referring to acceleration, which happens to be minus 32, but it has nothing to do with C.
So C
Right?
is.
I want to know when the velocity is minus 32. So this was my velocity function. I set that equal to minus 32, and I solve for t. Turns out it's after 5 seconds. What about part D? Right, height is a position. So I go back to the position function, and how do I get that? What do I set up here? Do I plug in 117 for t? What do I do? What do I do?
Have it equal to 117.
Set it equal to 117. The height is that function. So I set it equal to 117. And now I just want to solve for t. Because they asked me when. When means find t. How do I solve that for t? No.
Got T alone.
How? You have a t squared and a t. What do I do?
Factor it out.
Factor what out? No.
You still have a T inside.
Yeah.
We subtract 117, put it inside, and then
Right, it's a quadratic. You get
Yeah.
everything to one side equals 0.
Yeah.
So what do I get here? Minus 112. Now I factor. What can I factor? 16 goes into this? Does it?
yeah.
It does? That would be nice. 16 goes into 128 how many times?
8 times.
And it goes into 112?
Hello.
That's nice. And so now that seems pretty factorable, I think. Like a 7 and a 1.
Mm-hmm.
and I need to get a minus 8, so they're both minus. And so if you don't see this right away, just keep dividing by 2 repeatedly until you eventually get it. It's not going to take that long. Or I'd probably divide by 4
Yeah.
at a time, and you'll eventually get to that. So at this point, you can say that t equals 7 and t equals 1, right? So there are 2 times, right? How does that make sense? It's because it goes up and then down, right? So at the first point is at 117, it's on its way up, and then that's after t equals 1 second. The next time it hits 117, it's on its way down. That's when t equals 7, right? So you're actually at that position twice, right? Of course, there could be a situation where one of these might give you a negative answer. You of course do like that because we don't have a DeLorean.
So the equation that we started with is equal to the height?
Yeah, that's what they said that in the word problem.
Oh.
That the height is given by this one. Yeah.
That's a ground controlled major tone.
Yeah. Yeah. Any other questions? Any other ones you guys were looking at?
All 2009.
We can also like fall, 2009.
And I guess I asked you problem 1.
Yes.
So we find the derivative. So what do we need here? What rule? The first one. Product rule. I have something times something else. Now to differentiate that something, I'm going to need the chain rule, but overall it's a product rule and there's a chain rule inside of it. Okay, so product rule says differentiate this, leave that alone. Plus, now I leave this alone, and I differentiate that, which is going to be what?
4 times 3x squared
To the third
Times 6x.
times the derivative of this guy, which is going to be 6x.
Question.
Yes.
When we first started, can we distribute the 2 to the x cubed minus 1 or no?
You could.
Okay.
To write this as just 2x cubed minus 2?
Yeah.
Yeah, that's okay.
Okay.
And at this point, can we do anything? Sure, they're common terms. This is a common term. That's a common term. 2 is also a common term. X is also a common term. So I can factor out 2x times 3x to the 4th plus 1 to the 3rd power.
But wait, the 3x to the 4 and the other one is 3x to the 2nd.
Oh, is only square plus 1?
So yeah.
That should be a square. That was a typo.
Okay.
And so I took out the 2, that's gone. I took out an x, so I'm just left with 3x here. Took out 3 of those, so there's just 1 of those guys left. Plus, I took out the 2, this guy stays. The 4 stays. Took out that. Took out the x, so the 6 stays. So it's 2x times 3x squared plus 1 cubed times, this would be 9x cubed, 9x cubed plus 3x plus 4 times 6, 24, so 24x cubed minus 24. So it's 9x cubed plus 24x cubed, this would be 33x cubed, plus 3x minus 24. And that's your answer. Huh?
So what if you just left it like where you got the brackets at? 3 points is that? Like if I just stop with the brackets there, if I get confused. No, I'm with that. Like if I stop right there, like if I stop right there, how many points is that? It's like 6, right?
Let's say this was worth 10 points, 6 or 7.
That's
You should practice getting to here because in future sections it's going to be very important to factor fully. Because we're often going to want to know where the derivative is 0, so you're going to want to set this equal to 0 and solve for it. And to do that, you're going to need to factor. Yeah, so part B, this was part A. Part B is equal to B to the 4x over 4 plus x.
Because when we get to new, you see how there's a 4 on the first problem we did? 4 times 3x squared plus 1 cubed. First or second line? A little more to the left. Where did you move that 4 on to the next line? Like what
This 4 is here,
Oh.
and the 6 is here. The x I took out, this 2 I took out,
Hmm.
and then all of this I took out.
Okay, that makes sense.
So the x cubed was first, the 4 was second,
Mhm.
this was gone, the 6 was left.
Gotcha.
What rule? Quotient rule, right? I do have a constant on the top or the bottom, so I'm not gonna like manipulate it to use the chain rule or anything. I'm just gonna jump into the quotient rule. What does the quotient rule say?
F prime times g minus f times g prime over g squared.
Right. When you're practicing, every time you're using a rule, write it down. Yes, that's the quotient rule. So I'm going to have, so y prime equals
4e to the 4x.
Okay.
the bottom times the derivative of the top, so that's 4e to the 4x times that minus this times the derivative of the bottom, which is
1.
no,
1.
1 over bottom squared. At this point, e to the 4x is a common term, so we factor that out. I would be left with 4 times 4 plus x minus 1. Plus 4x. So that's your answer. C, y is equal to ln of x squared minus ln of x squared. Okay, what rule do we use? This guy uses a chain rule, right? Because I have an inside function and an outside function. What rule do I use here?
ln rule.
Which looks like what?
The derivative of the top over the original.
Derivative of ln u is u prime over u. Okay. And so y prime would be differentiate the outside, leave the inside alone, multiply by derivative of the inside. Derivative of ln x is
1 over
1 over x minus, this is going to be
2x.
2x over x squared. X is cancelled. So I have 2 ln x over x minus 2 over x. Or I can just put like 2 ln x minus 2 over x. So that's 1. I guess I also assigned 5. Over 4 minus 5x. So you see that. What should the derivative be? Let's do the shortcut. So if my y is equal to 2 over 4 minus 5x, how do you differentiate that? Bring it up. So I take y is 2 times 4 minus 5x to the minus 1. So my y prime is going to be minus 2 times 4 minus 5x to the minus 2 times times minus 5. And so it becomes 10 over 4 minus 5x to the square. So when you go through that whole limit, that's what you should get. Do that in the corner. So now we're going to have f prime of x is the limit as h approaches 0 of f of x plus h minus f of x over h. Its limit as h approaches 0 going here. Replace all x's with x plus h. Here write the original function. And that's all over h. We have a complex fraction. So I'm going to multiply top and bottom by the LCD, which is, in this case, just going to be the product of the denominators. Keep the limit because I didn't take it yet. Multiply out. In the first one, this guy's going to cancel. I'm going to be left over with that. So I have 2 times 4 minus 5x minus 2. In the second one, this guy's going to cancel. So I'm going to be left with 4 minus 5x all over h times 4 minus 5x times 4 minus 5 plus h. And what do I have here? I'm going to have 8 minus 10x minus 8 plus 10x
Plus 10h.
plus 10h all over
H.
that guy, h times 4 minus 5x times 4 minus 5x plus h. So here the 8, the 10x dies, the h will cancel with that, so I'm left with a 10 on the top. And at the denominator now I can plug in h equals 0 and I don't get 0, so I'm going to do that. So I'm going to have 10 over 4 minus 5x times 4 minus 5x. Thank God for the chain rule. Yeah, so it says using the definition, find, this is following it, compute f prime of 2. So they actually asked us for f prime of 2. So this means that my f prime of 2 is, I'm just going to plug in 2 into that form. So it's 10 over 4 minus 5 times 2 squared. It's 10 over 4 minus 10 is minus 6. And so then you square that, so you get 10 over 36, which is what, 5 over 6. So that's your f prime of 2. Use the result of part A to find the tangent line to the curve at the point x equals 2. So this is part B. Tangent line at x equals 2. So I know that my m is 5/18. I know that my x is 2. And then my y is just going to be that formula where I plug in x equals 2. 4 minus 5 times 2, which gives me that minus 6 in the bottom, right, which is minus a third. And so now my tangent line is y minus y1 equals m x minus x1. So y minus my y value, which means it plus a third, equals m, which is 5/18 times x minus my x value, which is 2. That's my tangent line.
Professor, what did you do with the H over there? In the corner?
Which one?
The top. You crossed it out. How did you cross it out?
Oh, because these guys all died, so they're not there. And I have 10h cancels this h here.
Okay. And then what happened to the other H, the x plus H at the end?
You put a 0.
Oh, I took the limit.
Got it.
Right, so once that h is cancelled, I can plug in h equals 0. So I plug in h equals 0 here, so this just becomes 5x. And that's just this. Did I ask another problem here? Maybe 10? Right, it's another velocity problem. Right, a toy rocket is fired straight up into the air and its height is given by this function. So this is problem 10 in fall 9. Height function is 160t minus 16t squared. What is the rocket's initial velocity? A. I want the initial velocity. What is initial velocity? Velocity at time equals 0. Okay, so how do I get that? No.
Take the
You first have to find the velocity. So the velocity is the derivative of the position, which is
160 minus 32t.
and so this means V0 equals 160 is initial velocity. In whatever units they told. Feet per second. Feet per second. What is the acceleration when t equals 3?
Double prime.
Double prime of the original, or the derivative of that, the velocity function.
That v equals what?
So it says acceleration at t equals 3. So first I find the acceleration function, which is just the derivative of my velocity function,
Just negative.
-32. So the acceleration at 3 is just minus 32. It's 1 feet per second squared. See, velocity when it hits the ground.
Wouldn't that be the same as the first one, 0?
No,
you equal it.
it fires upwards, so it doesn't hit the ground.
After it hits the ground, it's 0.
That means when it comes back down.
We just have the whole thing equals.
Yeah, so how fast does it hit the ground? When does it hit the ground? When position function is 0. So hits ground means your s of t is 0. So you need to know when is the position function 0. That's the height above the ground. So this means I need 160 t t minus 16t squared equals 0. At this point I can factor out 16t. I'd be left with 10 minus t. So this means t equals 0, which is the beginning, which is it's on its way up, or t equals 10. So this is what I want. So I want the velocity when t equals 10. So I go back to my velocity function, I'm going to plug in 10. So it's 160 minus 320, which is what, minus 160? So it comes back crashing on the ground at 160 feet per second. The negative indicates that it's on its way down.
So wait, again, why'd you use t equals 10?
That's after it hits the floor.
T equals 0 is initial.
Equals initial.
That's when it's on its way up. It's not hitting the ground, it's on its way up. So it actually goes up, then back down. T equals 0 is where it started, T equals 10 is when it dies. Okay, anything else? How about this one? Fall 2010. One D. Find the derivative.
Come on.
1 over everything.
Just omit it.
What's the derivative?
1 over everything.
Times the derivative of that? You want to do the derivative of that?
Sure.
Isn't that ln?
Sure, you can think of it that way.
Okay.
Could you bring up the 2x?
What do you mean? I write 2x to the minus 1 up here?
Yeah.
Oh yeah, ln subtraction, ln all that subtract by ln.
Wait,
It's an
ln.
ln. Use the log
Yeah, the
rules.
log rules.
This is just ln of 2x squared plus 1 to the 5th plus ln of e to the minus 7x plus ln of 3x squared plus x plus 1 minus ln of 2x. Right? Which in fact you can even make it easier. I can take this power and move it down. Ln and e actually kill each other. So I have 5 ln of 2x squared plus 1 minus 7x plus ln of 3x squared plus x plus 1 minus ln of 2x. Which means at this point I can start to find my derivative. This is just a constant, leave it alone. Derivative of this, what's the derivative of this? Ln of this.
4x over 2x squared plus 1.
Right, derivative of the thing times over itself. Derivative of minus 7x.
Minus 7.
Derivative of this.
6x plus 1 over 2x squared plus x.
Derivative of this.
2? No. Yeah, 2 over 2x.
2 over 2x, and the 2's cancel. And then that's it.
Can we do a marginal cost? Please.
Are any of those on the finals?
No.
Okay, just choose a homework problem. So here we're doing section 3.2. Here's also a fun one. Let's do problem 9 and then we do a marginal cost one. So we're told that f of 40 is equal to 378. F prime of 40 is equal to 6. Estimate f of 42 and f of 38.5.
Is this linear
And maybe
approximation?
problem 19 is what we'll do after that. Maybe skipping part C. Because that'll be easier work after we cover a few topics. Yeah, so let's do that. Okay. What's up of 42?
What's the first step?
What should we be using here? Let's figure out.
Oh, the f of a minus x.
Right, linear approximation. What's the formula for that?
F of x. The squiggly lines.
It's approximately equal to.
F of a plus f prime of a. X minus a.
And x minus a. Right? Remember, x is the ugly number that you want to approximate. A is the nice number that you already know the values for. So this means that if I want to find f of 42, this is approximately equal to something close to that, 40, plus f prime of 40 times x minus a. So in this case, my x is actually 42 minus 40. So f of 40, I was given was 378, plus f prime of 40 is 6 times 42 minus 40 is 2. So that's 378 plus 12, that gives me what? 390? Similarly,
Oh, isn't it 80? Never mind.
Wait, how did you get the a deeper in?
oh, this is my x, this is my a.
Oh, okay.
Remember, x is the value that we don't know, it's not the nice value. A is the value that's nice that we already know the answers for. Similarly, if I wanted to figure out what is f of 38.5, I could take that as my x. 38.5 is relatively close to 40, I guess, so we would use that. So it's going to be 38.5 minus 40. That's 378 plus 6 times, what's that, minus 2.5, minus 1.5. So that's actually is that 6? Where's that? Decimals. 0 over 2 is 1.5. 2 into that goes 3 times, that's 9. And so this is equal to 378 minus 9.
316.
Problem 19. they gave you two functions. A manufacturer of power supplies estimates that it will incur a total cost of blah. So it gave you a cost function, C of Q, 2,500 plus 4Q plus 0.005 Q. And it will collect, it also gave you a revenue function. So it's going to be 16Q minus 0.002Q squared. Write down the profit function. How do you find the profit function? Yeah. Profit function is just the revenue minus the cost, right? Revenue is the amount of money you make when you sell something. Cost is how much it costs you to produce it. So it's just R of Q minus C of Q. And so that's going to be 16Q minus 4Q, 12Q minus 2,500. That gets rid of those guys. And then I'm going to have minus 0.002 minus that, so that's minus 0.007Q squared. It says find the marginal cost function and the marginal revenue function. So if I ask for a marginal cost, what is that?
The derivative.
Right, marginal cost is just the derivative of the cost function, which is going to be what here?
4 plus 0.005 Q, no, 0.005.
0.005 times 2,
2.
which is what, 0.01?
Yeah.
0.01, yeah.
And the revenue, marginal revenue, is just the derivative of the revenue function, which is just going to be 16 minus 0.04Q. In a test, I wouldn't ask you something like part C, but I'd probably ask you something like this. What is the cost producing the supplies? So let's say the 101st. Well, what is it? That's just the marginal cost at 100, basically. So remember the marginal cost, that's approximately C of 101 minus C of 100. So that basically I'm going to just go here and plug in 100. 4 plus 0.01 times 100. Right? Remember the marginal cost is just it's the approximate cost it will take to produce one more item given that you've already produced 2 items. So if I want to know how much it's going to cost to produce the 101st, look at what it cost me to produce the 100th one and take the derivative at that point. And that's going to be approximately what's going to cost me to produce that 101st one, which is $5 or 5 thousandths of dollars or $5. Yeah, so something like that. Not gonna go crazy. Yeah. Go home.